Okay, so I'm going to talk about REST API design for connected devices, but you folks are already really savvy about API, so this talk probably isn't for you directly. It's more for us as a group to go evangelize the API approach to IoT. And have you heard the phrase Internet of Things before, by show of hands? If you have heard the phrase Internet of Things. Okay. Have you heard the phrase the bus of things before? No. And there's a good reason for that, because it's a really dumb idea to do the bus of things at the scale we're trying to achieve with the Internet of Things. However, when you talk to two groups of people, the first, there are two groups of people that are really invested in the idea of bus technologies already, which is really important in some use cases. There's the device guys who create complicated devices like automobiles. There's a standard called CAN bus, which is how all of the devices on an automobile interact with one another. Appliances are the same way. You know, if your washing machine has like 3 or 4 actuators and sensors on it, they all communicate on a bus. The other group of folks are like the big cloud companies that are actually invested in selling bus software. So what happens is you get the IBMs who, or maybe not to be too specific, but the folks who have investments in bus technology, they get in a room with the guys who have investments in bus technology and the devices, and they're like, oh, it's all buses, and that's going to work great. But then they call it the Internet of Things without bringing any of the Internet stuff along, which is really important. So this talk is really just to say, if you look at the world from API colored glasses, like we all do anyway, this is going to be like a really common sense, straightforward application of API thinking to devices. But it's important that we realize that not everyone understands this stuff. So we have to take this and evangelize it forward so we don't do things the wrong way, which is, we're seeing that a lot. So on that note, along with Apigee, we created a really fantastic vendor-neutral international group of folks called API Craft. It's an online group. Has anyone heard of this before? API Craft, a couple folks. So if you have API questions, it's a great spot to do discussions. There's about 5,000 people. It's a very civilized place to talk about everything from API design to API business models. I suggest checking that out. Whereas this has 5,000, this one has about 5. We just launched it a couple weeks ago. This is called IoT Craft. What both of these groups have in common is this sense of doing craftsmanship, like really trying to craft smart solutions to problems instead of just evangelizing or doing whatever. So I recommend you check these two out. Okay, so we did sponsor this event, so I had to do this obligatory commercial, and then you won't hear from any more stuff about Apigee. But we launched an open source project in September called Zeta, which is all the ideas that I'm going to talk about here. This is an open source project built on Node.js that does all this stuff. Pretty much the vision is to turn any device into a fantastic Hypermedia REST API. We also just launched a 4-pay, very expensive version of this called Apigee Link, which you can buy from our sales reps who are in the back of the room. Okay, end of commercial. Now let's get on to the content. So there's 2 great videos. My last startup I did was called Swivel. Andreas reminded me of this the other day, which Swivel, the idea was that we can aggregate a bunch of data and then visualize it, and you can comment in it like YouTube. And we raised $4 million, and we spent it all, and we never made any revenue at all. It was a total failure. And the 2 reasons that it really failed was it was way before APIs, and more importantly, it was way before OAuth. So there was no way for people to kind of share their data in a secure way with apps that they didn't really trust. Back then, there was this video that was circulating. I think it was on the streets of Stockholm. They just asked random kids, what do you use the internet for? And for me, I was on the internet in 1994. You use the internet to go through your Mosaic browser to access the physics data at CERN. That's what the internet is for. And these kids were using it to meet people. I was like, meet people? That's not what you do with the internet. So the internet has really changed a lot since then. But so there's like 2 generations. There's these folks who date and marry and everything online, that happened after I was on the internet. And then there's like my dad coming to the internet now. So this is my dad. Oh, actually, so there are these people, right? This is people who are going to fall in love using the internet. And then this is my dad, right? This is how he goes to the internet. Right, so this is him at Yahoo typing in HTTP : to get to Facebook, right? Like that's, for him, if you say, what's the internet? The picture that comes to mind is this one. I'm from Michigan, right? We have a big rivalry with Ohio. I love that unemployed Ohio people are also, they do this, as well as people who use Garmin still, which is a pure play GPS provider. So there's definitely the technology laggards are doing it this way. But the question for me is, and for you is, if you just blank out your mind and somebody says internet, what's the picture that's in your mind's eye? Like, what is it that you see when you see that? So keep that in mind, because this is the contrast between the people who think about things in terms of buses. Which brings us to the next question, which is, what is the Internet of Things? So here's one really solid aspect of the Internet of Things, which is essentially you turn your smartphone device into a glorified remote control. right? I can see things that are happening with it, and I can make changes to it. We already have this today. For example, Philips Hue is sort of the innovator here. Nest is the innovator here with a connected thermostat. GM had their first connected car back in the 1990s, and they were the first ones to adopt smartphones. They actually have a fantastic API program as well. In terms of the rest of these guys, their API story is really abysmal. Like, my intention for this slide deck was actually to go look at all of the leading internet technology devices and do sort of compare and contrast on their API design, except they're all so horrible, and they're hidden behind these like manual registration walls. I couldn't even get to anything meaningful to share stuff with you, so totally changed the presentation based on that. So this is one idea. Remote control your devices. Here's another idea, which is one really important slice of it, which is wearable computing, right? So the idea that you've got your smart glasses and your smartwatch, here's my Pebble, and your phone and your laptop. Is anybody living in this world yet where they've got all this stuff attached to them? No. In our IoT lab, we have all this stuff, and the first day I got my Google glasses, I already had all this stuff going on, and then this thing happened where I was sitting there, and all of a sudden it felt like the table started shaking, and my head starts buzzing, and it felt like there was kind of a miniature, like really localized earthquake. And what had happened was I got a text message, right? And the phone calls are even worse, right? Because sometimes the Bluetooth isn't as speedy as it needs to, so you answer the phone call on one device, but the watch is still buzzing as you're holding it like this. So it's really unnerving. So, and then we want to add more stuff. We want to add robots and autonomous vehicles and the connected home, right? So this is current state. Right, and if it's like that, you can keep it, frankly. I got rid of all that stuff for the most part. So that's like sort of one version of the Internet of Things. Here's another thing. This is a common scenario that happens. I have an old Ford Explorer, which has a really leaky rear passenger wheel. So oftentimes, I'll be driving down the road, and the little dummy light will light up and say, hey, your rear tire is low, which is fantastic. I mean, there's a sensor that somebody has built that can stand these huge swings in thermodynamics, right, from below freezing temperatures to really hot temperatures, and it always accurately tells you the tire pressure sensor. It's a really fantastic achievement of physics and engineering, and it's hooked up to this CAN bus to circulate within the vehicle that data, right? And if I wanted to, I could even put my ODP port adapter on it and have access to that via the smartphone to get that previous version, which is great. But what I really want to have happen is when I pull up into the service station to fill that air up, what happens now is I go to the pump and I pull that cable off, and then I realize that it only takes coins, so I go back into the front desk and I beg that guy, can you break this bill to give me coins, and then I put the coin into it. And then I do this dance where I take my old hand meter and I put it on the tire and I go like this, right? Thinking, has anyone ever died by overexposing their, blowing up too much air in their tire, until I get the pressure that I need, which is really a waste of time because the tire already knows how full it is, right? For like $30, I could put all the electronics I need on that actuator to just have them talk to one another, right? So what I really want to have happen is these guys can just communicate, but they're not, right? So if you look at these two problems, you could ask, in the one case, it looks like hyperconnectivity. There's too much stuff, and in the second one, it looks like no connectivity. So is that what's going on, or is there really something deeper here? And this is what I think is going on. There's actually something deeper happening, and it all comes back to Kevin Bacon. Has anyone heard this before about how many degrees of separation Kevin Bacon is from any other act? Does anybody know what field of mathematics that comes from? Graph theory. Who said that? Okay, beer for you later. Thank you. Graph theory, right? So in graph theory terms, that you frame that problem as what is the diameter of the graph, which is like what is the average distance from any two nodes in the graph. It kind of gives you a sense of the width of the thing. So when we started this IoT project that I mentioned before, this was our starting point, is what is the diameter of the Internet of Things? Like in the case of the tire pressure sensor and the air compressor, it's like infinite. They're not connected. They're not even in the same graph, right? In the case of the wearables, they're sort of connected. Like clearly the message comes in, everybody got the message, but they're connected, but they're not in communication. They're not really at the application level, they're not really working in a very strong way. So when we go back to that original question was, when somebody says internet, what's the picture that comes in your mind? For me, this is more or less the picture that I think of. It's about nodes and arcs, right? In the world of UI, that's about the hyperlink, right? The hyperlink is the most beautiful thing ever invented, right? It's really what made traversal of the web work, and it made it easy for people to get across things. In the world of the Internet of Things, these are really API connections, right? So the second question then is, if the diameter of the Internet of Things is really big, how do we make it smaller? And that's what we've been trying to do. If we think about the social web, this is what this looks like, right? This is the content that Travis and Jacob just shared is some of the best OAuth content I've seen. And I've consumed a lot, and I've actually created a lot. It's just really clean, crisp stuff. So I plan to share that with a lot of folks. But the idea here is a lot of people have done this where they say, hey, I want my Instagram photos to show up in my Facebook feed. So what do? They get an app that allows that connection to happen using the whole delegated auth dance. It's really, really important innovation. We take it for granted every day. But this is exactly the thing that's missing from my other scenario, right? What I want to have happen is when I pull up to that service station, I want to delegate the card data to the service station to say, hey, you guys are allowed to see the tire pressure sensor. And as it's filling up, just have the air pump stop when it's full, right? That would delete the diameter of the Internet of Things down to 1 in that case, right? Because they'd be directly connected, right? This is the type of thing where if the IoT is really going to work, this is the valuable stuff that we need to see. So another way to put this is, to truly achieve the Internet of Things, we need recombinant devices, right? And what we mean by recombinant is the combination of data flowing over Internet protocols and delegated auth, okay? In other words, we need a REST API for every device. That's really what it comes down to. And the reason that if we go back to what I said about the beginning, the contrast between the bus of things and the Internet of Things, we should be in a race to, as quickly as possible, move the device world over into the API world. Because as soon as we do that, a lot of these other questions, like this one, get solved by a whole ecosystem of technology and really smart people like you just saw from Travis and Jacob that can actually help us solve that stuff. Otherwise, those guys are going to go reinvent it themselves and they're going to get it wrong, right? So that's what it looks like. Now, when we started Apigee, instead of device API, this was just, we just called it API, and instead of a device maker here, this was like traditional IT, right? These were the guys who were doing the SOAP stack, had done service-oriented architecture, and they needed to translate that stuff into a device API. And it was here when we drew this on the whiteboard that we started this term saying the API is a product and the developer is a customer. You might have heard that around the API ecosystem, right? It was when we drew that on the whiteboard that's where that insight came in, right? So in the world of IoT, that's still true, right? I want that app developer to create that really great app between the air pump and my car, right? So for him to do that, there needs to be 2 great APIs out there, one for the car and one for the air pump, right? The problem is these guys are from a totally different world. I've got a friend from Genoa, and he said there's 2 kinds of Italians. They're the Italians who just live life every day, and then there are born to suffer Italians. He's from the born to suffer Italians, where he worked in his father's bakery and had to wake up every morning at 4 a.m. to bake bread. These are born to suffer engineers. These guys are the I love to party engineers, right? These guys, if you fill up 2 terabytes in the cloud, you're like high-fiving everybody, like, yeah, you can monetize data. This is awesome. These guys over here, if you can get your little bit of code down from, say, 64 kilobytes down to like 8, you just saved your unit. You cut your unit cost by like 1/8, which means instead of making $8 million, you make $64 million in revenue, right? So these guys are like crazy, like resource constrained, and they're totally different thinkers. We've learned this the hard way because we started selling stuff to these guys, and they're from another planet, right? But it's really fun stuff. So if we were to look at this, we have to keep in mind that even for these device guys, they need to understand that that's the customer and the API is the product. So, but these guys don't understand REST APIs. Like this demo that I'm going to show you, this is from our first customer for our product. They're really, really good at Zigbee radio. In fact, they sit on all the standards bodies. They're the best in the world at the Zigbee radio. The only person that knows anything about the web is the guy that runs their brochureware website that they outsourced. Right? They've never touched HTTP. They don't know anything about it. Right? So that's an issue. So let's show this demo if everything works. There's no promise that it will. Okay, so you can kind of see this. That's me. Okay, the lag's not too bad. So what you have here is this is a I hope I don't block your view. This is a BeagleBone Black. Anyone heard of this? It's a single board computer like the Raspberry Pi. Have you heard of the Raspberry Pi? Yeah, very similar. This one is actually made by Texas Instruments as their prototyping board. So this has, right here, you have a Zigbee radio antenna. It's got an Ethernet cable connection here. There's just a local Wi-Fi network that I'm connected to on my laptop. Here you have a thermometer. You have a motion detector, a water sensor, Oh no, I'm sorry, that's a smoke detector, a water sensor. This is a reed switch that we would put on a door or a window to see if it's open or closed. This is a night light. These are relays that control lights in this panel. And then here's a third-party smart door lock. Okay, so how would you turn that stuff into an API? That's exactly what this company came to us asking the question. So we showed them, and I'll show you now. So let's see here. So this is the door lock. What I'm showing you here is a web app, which is really, it's just a Hypermedia client. Does anybody know what that means, right? So this is actually generating a Hypermedia API, and this client doesn't really know any details about the actual stuff. It just reads the Hypermedia API and traverses the tree and generates stuff. So if it sees an action, it generates a button, right? If it sees a WebSocket, it subscribes to it and visualizes it up here. Okay, so we're going to dig into this stuff. So essentially, to see this door lock, I just come down here and I issue this API request. So this is saying, of all the servers in the world, give me this one, which is called, this is their Centralite CES demo. It's what they gave in Vegas. And then of all the devices on this server, give me this one with this unique identifier, right? And then once I get that, this is actually based on Siren. Have you heard of Siren Hypermedia? There's a bunch of Hypermedia standards. One is called HAL. There's JSON collection. Siren is one of those. The reason we chose this is because the head engineer on this project is the inventor of Siren Hypermedia, so there's no way we're going to go with a different standard than that one. So when I do my Git here are the properties I can see for the door lock, the active power. There's the IEEE standard. I don't understand it. The device guys do. And then here's a list of actions, right? So if I want to lock this door lock, I'm just going to send it an HTTP post to this address with this payload, and that'll lock the door. Once it's locked, and then I made another request to the device, it will have changed state, and this action won't be available anymore. The only state that will be available is unlock, right? So what that means now is if I create an iPhone app on top of this device, the iPhone app doesn't need any it doesn't need to know the device and how it works. It just needs to know how to read the API and sort of generically render UI widgets, which is really important in the device world because you don't want to make a device update and then have to wait for your users to download and say, yes, I finally get around to update this app on my iPhone. That cycle will kill you. And plus, when you create a brand new device type that has a totally different state machine, you don't want to have to re-release through the App Store that app. You just want to say, I've got a new device, and because it's a Hypermedia API, this stuff just works. So now, if the demo gods are with us, we'll try to actually do something here. So let's try to lock the door. Right now it's unlocked. So please work. There it is. Did you hear it and see it? We just locked the door. Okay. Now what I'm going to do here is come over here and unlock it. So I'm just going to turn this guy here, and you'll see that the state is going to change over there in a second. So I just manually unlocked the door, right? So we sold this to Centralite, who used our stuff to build this API, but they were also to take this third-party lock from another company called Yale and make that work as well. Because once they got the idea of wrapping a device in an API, they were off and running. Like, we didn't have to tell them anything else. They just knew the fundamentals of how to make it happen, which is how we're going to grow these really fantastic IoT ecosystems. Okay, let me show you one more sensor. So this is the door sensor. That's this guy here. There's a little reed switch. So if I pull it off, you see that it changed from closed to open. If I put it back on, oh, that's the wrong, that was a test. Thank you. If I put it back on, it closes, right? So how does that work? If we look into this API, down here, in this API response, it's telling me that there are two WebSockets that I can subscribe to. One tells me the current state of the door sensor, and the other one is on every device that we have, which is just the log, right? The log is just going to constantly tell you whenever there's a state change of any kind that you can subscribe to. If I take this guy here, just for all of us geeks that actually spend time in the console every day, here's a console, right? So all I'm going to do here is do a cat, WSCat, WebSocket cat, on that device. And then once it's connected to it, I'm just going to show you the raw data that's actually coming back and forth here, right? So if I pull that off, you saw that it opened, close, open, see? Right? So this is just sending WebSocket data, right? Before we got to that state with these guys, the stuff that I can tell you that they plan to do to make all this stuff work would have made your eyes spin. You're like, why are you going, these problems have already been solved. Like, WebSockets are what you use to get data over the web. You know, HTTP is what you use to build smartphones on top of, right? But they were coming at it from a totally different sort of bus perspective. So my point is, I can't stress enough how important it is that if you've got this knowledge about how APIs and internet works, we have to go take this to the world of the device guys. Okay, and then sort of some last thoughts here. So this demo that I just showed you, this is sort of our sort of schematic architecture of what this stuff looks like. You've got a bunch of devices scattered around here, from wearables and appliances and cars and smart infrastructure, and then you've got clients that can consume it. Our goal with this stuff is how quickly can we turn all of these device things into the world that we know and love, which is around HTTP and WebSockets. That's the mission, right? In the case of this door sensor that I just showed you, it's starting as a very primitive Zigbee device. So we need to pretty much start here, do what I've been calling information amplification, right? We need to take that little tiny Zigbee radio signal and amplify it so that it becomes a WebSocket that you can consume in the iPhone, right? So in this case, what we do is we run our open source Zeta thing here on that BeagleBone Black, or it could be a Raspberry Pi. And then this connects to the web where we have another Zeta server running. And then this guy then spreads that information out there. There's plenty of cases where you don't need a hub. For example, the connected car is already kind of a hub itself, right? In which case you can use a smaller protocol like SMS or MQTT, and then that will communicate to our stuff running in the cloud, which will then do this sort of transformation into a really strong REST API. So I love this. I love this space because we get to think about design. I just love where sort of like problems and solutions meet around design. It's just, for me, it's like tickles my brain better than any problem space that I've worked on. And this, for me, is like a really like full circle thing. Like, I studied physics back in the day where I thought I would be working in an experimental physics lab, just didn't pay very well. So to come back to a world where we can take the physical and the digital and combine it has been super stimulating. I've really enjoyed it. And I think there's some lessons we can learn here, right? So back in the day, this is the Oldsmobile car company in Detroit. Detroit device guys were so way far out in front of the information design people, and I'll tell you what I mean by that, that it caused a lot of problems, right? We were cranking out so many cars into the streets of Detroit. A lot of them left on boats and on trains to other parts of the world, but a big chunk of them stayed right there, right, where we invented, you know, mass-scale automotive production. So we hadn't thought about these problems. Like, what do you do when cars come to an intersection? It used to be just horses and buggies and peoples, and they would just figure it out, right? But you can't do it when they're, you know, this heavy and this big, right? So there was a problem there. Another problem was people just would kind of like double park or triple park, and there really was no sense of what the road was for. We had to figure that stuff out. We didn't have that information design yet. So whenever somebody would like cross over like a lane that didn't exist yet, you know, you would get accidents like this. This is a picture of the east side of Detroit. There were no parks then. The roads were the parks. Everybody played in the street. That's just what they did, which is really bad news with cars, right? This woman actually died, which is kind of morbid, but she's actually stepping into the street, and you can see this guy just started to turn his tires, but didn't get there in time, because people were just used to walking out in the street because it was their street. And all that had to change, right? This chaos of horses and all that stuff, it just didn't work very well. So Apigee is based in San Jose, California. We've got people all over the world. We have our IoT lab is this really tiny group, which is in Detroit. And our lab is actually right here in the building behind this one. All of this stuff that we take for granted was invented like within 5 blocks of our office where we work, right? The world's first ever concrete road was Woodward. It was called M1, Michigan 1. It's this road right here. The first below-grade freeway is the Davis images right here. Right? It's the first time they sunk a road below grade. The first lane markers were created by a guy named Edward Hines. He was driving home. He was the road commissioner of Wayne County. He was driving home behind a milk truck, which was leaking, and it was dropping these blotches of milk on the road in this pattern. He was like, we can use this as lane markers, right? Because they weren't sure how to do it. So that's where lane markers were invented. The first pedestrian crossing was right here at the corner of Gratiot and Woodward. This is, in order to do it, they actually went to the local country club and borrowed their, the machine they used to paint the tennis lines. Right? And they created the first pedestrian marking. The first stop sign was right here at Jefferson and Woodward. And then also a cop by the name of William Potts invented the red, yellow, green traffic light, which you see all over the world. So these were just people just trying to solve problems, and they became information designers sort of as a byproduct of them, of solving stuff, right? So for me, this is kind of the key point for the device guys is, you know, this is a Detroit cop explaining to school children how the red, yellow, green traffic light worked, right? You'd have to teach somebody that is like a crazy concept. So for me, this is kind of where I feel like we are in the world of IoT, right? The device guys are pushing all this stuff into the market. with IP connectivity, but they really don't know how to take it past that. And that's really where our community comes in, is to help sort of evolve beyond that. And it needs to be universal, right? This is actually just down the street from the hotel here. I forget which intersection it is. But all that stuff that was invented, you see, right? There's the pedestrian way, you know, here, there's the traffic light, right? So it's everywhere now, we don't even see it, right? So that's where we need to get through with this stuff. That was my talk. If you want to check this stuff out for the open source hands-on guys, you can go to zetajs.org. There's a nice little community growing up around that. Check out API Craft and IoT Craft. You can follow me. I'm on Twitter at landlessness. You can send me an email, and then this is our Twitter account for the IoT project. I have no idea how I did that time. Am I way over?